Good morning and afternoon, everyone. Kevin Sato, the program scientist for exploration in the Biological Physical Sciences Division. And what I want to present today is just a little background on the biological and physical sciences and what we do, as well as the update on what we're currently doing to advance our scientific research to Moon and Mars. If I could, next slide, please. We have new division leadership. Dr. Lisa Carnell is now our BPS Division Director, and Diana Lee is now our Deputy Division Director. They both have extensive experience and background in scientific areas of biological and physical sciences, and they also have many years of working within the division as well. And so we're really excited that that they've come on as our leaders to take us forward. Next slide, please. In September, we had our decadal survey released. We are currently in the process of digesting that information and developing plans and roadmaps and other objectives to meet those recommendations and findings that are in the decadal. And if you haven't seen it yet, please go to the report's websites or get a copy and peruse through it. There's a lot of really great information, and it really does represent what our science community has been looking for and asking for over the many years that we have been conducting research in space. Next slide, please. So what is the Biological and Physical Sciences Division? We're made up of principally three different programs. The life sciences, which includes everything that's biological, including what I don't have on this is microbiology. The physical sciences area, as well as fundamental physics. And our purpose for going to the moon is that it provides a very unique opportunity to study each of these areas of scientific endeavor, from the 1/6 gravity to the lunar surface albedo radiation and deep space radiation to unique factors and distance. So there's many different things that are directly applicable to the science that we do. And some of them are applicable to really understanding the difference between microgravity, where we've done much of our research in low Earth orbit, and to the true deep space radiation environments, as well as the partial gravity environments. Next slide, please. No, so we have four basic tenets that we follow within the Biological Physical Sciences Division. One is scientific discovery and advancement of knowledge through grants, collaborations with other government agencies. But within the research grants in our science, we're also heavily involved in open science. So all of our data, as well as some specimen sharing, especially on the biological sides, are available to the community as a whole. And I suggest you take a look at our website, which is in the QR code, to get further information, as well as further information on the open science process for NASA and how we apply. But also, our research is complementary to and cross-cutting to other areas of science within the NASA directorates and external to industry as well. And so we use our data and our findings and our models that we're creating using fundamental research to inform and contribute to enabling sustained human presence off Earth in many different areas of safety as well as life support. Also, by returning that information for benefiting life on Earth with respect to different applications of biomedicine, technology, and agriculture. And then finally, using that information, especially from the areas related to biological and physical sciences, to supporting the commercial space industry in order to close the gaps needed for them to develop new products and applications to advance exploration and industrialization and commercialization of space. Next slide, please. This is our current fleet of flights, and as you'll see, we are principally in a low Earth orbit, conducting many of our research projects on the International Space Station, but we do have active science that is currently going to the moon. Leia, which is part of the CLIPS mission, CP-22, we have a payload that is going to be flying on Artemis 2, and as you've already heard, we are co-sponsoring LEAF with SEO. Next slide, please. So just a little bit more on our research investigations. Artemis 2's investigation is a tissue-on-a-chip experiment in order to look at human physiology using an analog of human biology through a tissue system that's built within a chip. It is a large collaborative endeavor between the Human Research Program, multi-government agencies, academia, as well as industry. On Artemis 3, as you've already heard, we are co-sponsoring with SEO Leaf, who the PI is Dr. Christine Escobar. Next slide, please. We are also hosting, then this is an SMD-wide activity, the Lunar Surface Science Workshop. It'll be on August 20th and is looking at science drivers and capabilities for lunar surface habitat research facilities. It is a virtual meeting, and we will be collecting comments and input from the science community and the industry through the different breakout sessions. So I would recommend that you take a look at the Lunar and Planetary Institute website for announcements if you're not getting a notification for this particular workshop. We are collecting community inputs for this one. Next slide, please. Also, we've issued a series of ground awards through NASA Space Biology for our BPS Space Biology program. These are really studies to kind of begin to do some seminal work and initial work on understanding how lunar regolith affects biological processes and systems. We have 9 studies that were awarded in plants and 2 animal models, systems, and cell cultures that were awarded in that area. And it's really looking at lunar regolith to simulate to begin to do those studies so we can expand that data into more expansive research both on Earth as well as on the moon. Next slide, please. Also, we are heavily involved in EPSCoR, and there were several investigations that were currently being submitted, and we're currently in the solicitation process, but many of those also have direct relevance to the lunar scientific area of research. And these EPSCoRs are for in states that have less represented universities and colleges than we normally see for in our major ROSES grants. So they're really, really useful to bringing in new scientists and students as well into our field of research. Next slide, please. I just wanted to let you know, Dr. Vogel mentioned this morning in his introductory presentation and welcome, but I would suggest you take a look at the STMD strategic plan. I've got the QR code link in the bottom. Although the call has been closed already, there's a lot of really, really great information and details related to knowledge gaps and areas of understanding that are still needed and shortfalls, as he mentioned. Many of those are also related to biological and physical sciences division research in terms of what we do fundamentally. So I would suggest if you haven't taken a look at this website, please go to it and have a read through it. There's a lot of really great information with respect to technology, space technology development that is applicable to many different areas within SMD as well. Next slide, please. And finally, I just wanted to let you all know that this year's American Society of Gravitational and Space Research, which is going to be December 3rd to the 7th, is going to be in San Juan, Puerto Rico. It brings together our diverse community of space life sciences, physical sciences, fundamental physics, to discuss scientific research and advancements and accomplishments, but also it brings together commercial industry as well as and government leadership into this meeting. So it's a very large and diverse meeting to really discuss everything science and science application and outwards to industry. Also, the ISS National Labs is involved too. And with that, that's my talk. Thank you very much.